Hello, my name is Evan Sinisek. I am recording a little demo slash go over for GDP 1 at Fanshawe for the Info 6028 graphics Project 1. I'm just going to say apologies in advance. I am recording this at 2:30 in the morning because I just got home from an 8-hour closing shift about an hour ago, and I have to close again tomorrow, and if I don't do this right now, there is a non-zero chance that I won't be able to do it in time before work tomorrow, so I might be a little bit rambly. But anyways, I want to start by quickly going over the code. In particular, the camera. Let's make this a little bigger because I'm going to be completely honest. I couldn't figure out how to do this on my own. So I went to Google and I found these two websites. I found this OpenGL tutorial keyboard and mouse first, but then I found this Learn OpenGL site, and it's more or less more what I ended up using. Basically, I figured out the mouse callback from the OpenGL tutorial, but I couldn't quite get it to work with the camera target, and I didn't fully understand it until I found the Learn OpenGL tutorial, and basically that's how I figured out pitch, which is the rotation of the camera around the x-axis, yaw, which is the rotation around the y-axis, and roll is the rotation around the z-axis of where the camera is currently facing. Also, I have music playing just to try and keep myself a little bit focused. If it's a little bit too loud or too distracting, let me know and I'll not do it for the next video. But anyways, yeah, so if the program just started when we first start moving the mouse, we set our last X and Y to wherever the mouse currently is, and then we cancel that out so that we don't keep doing it. Figure out the offset for where the mouse moved. Multiply it by sensitivity so that it's not too fast or too slow. Add it to our yaw and pitch. Hard set the pitch so that we don't start going through ourselves. And then this is really where the magic happens. More or less, where is it? Here. Basically using SOHCAHTOA to figure out what we need to figure out the X, Y, and Z based on projections in the XZ plane, and I think this is, yeah, and then the y-axis from the XZ plane. Anyways, this more or less makes a fly camera that wherever you look, based on the mouse movement, if I just completely copied that code, it would just be a fly camera that if I press W, we move into like towards whatever the camera's facing. I didn't want to do that. Because it was kind of awkward to control. So here in our key callback, escape to quit the program, have our camera speed. So WASD, this is how we used to do it, just moving towards the origin. But now, instead, whenever we press W, we add just the X component times the camera speed and just the Z component. This locks the Y so that we don't just follow wherever the camera is pointing. So then the same logic for S to go backwards. I don't really need these anymore. Yeah, this moves this camera in the same direction. I think that I'm supposed to say facing, but whatever. And then to move left and right, we calculate the cross product between whatever our target is and the world up vector, which is just 0, 1, 0. And then if we're moving to the right, we add it. If we're moving to the left, we subtract it. But I still wanted to be able to move the camera up and down. So using the world up vector, just to keep it consistent with everything else. Pressing Q makes us go down, and pressing E makes us go up, which we'll see in a moment. I'm still printing out the camera position just because it's useful to see, and as was part of our requirements in the rubric, pressing space key allows us to switch between wireframe and not wireframe, solid fill. So as far as the actual GLFW stuff, camera stuff first, actually. Error callback. Yeah. So these are going to be my load functions. But since I'm talking about the camera, again, trying to be honest, I tried to use SOHCAHTOA and Logic. Basically, I needed to have the yaw be at a specific rotation depending on where in the world we are so that it would face the origin whenever we move the camera. And my logic did not work, and I eventually figured these out through brute force. But long story short, this works, and wherever we place the camera, this will always make the camera face the origin. So if we are in positive X, positive Z, we do the inverse tan of the Z over X, converted to degrees, plus 180, because the yaw works in degrees, and then gets converted back to radians when we're doing the cosine sine for the direction. if we're in positive x, negative z, 90 minus the inverse tan. And then in negative x, positive z, and negative x, negative z, just the arc or inverse tangent worked. That was the one that kind of confused me the most. I expected these to, at least one of these, to need some kind of addition or subtraction. But anyways, if we're along the x-axis, we check if we're in the positive or negative z. If we're in the positive z, yaw is set to 270. If we're in the negative, yaw is set to 90. And if we're along the z-axis, if the camera is in the negative, the yaw is set to 0. And if we're in the positive, yaw is set to 180. And then to make sure that the camera target is always facing the origin, we just multiply the x and z of the camera I by -1 and normalize it. And then in our main while loop, this didn't really change from what we were given. This is our models for the vector. Yeah, this is all our models. This is the change to the camera. It used to just be camera target, because we were just looking at the origin. This basically treats the camera target more like the front of the camera that we're just facing, so we just add it to the camera I, and then our up vector is constant. And then the rest of this, I believe, stayed the same. I kept the color override hack in because I just wanted to always set color for this. And then here is the wireframe logic. If our wireframe boolean is true, I should follow the logic that I've been seeing from my professors and call that B wireframe. Anyways, if it's true, then we're in wireframe mode. If it's false, we're in fill mode. And then we just go through our vector of meshes and drawing them for everything that they're set for. Let's go change that booleans. Not going to change that one. And that should change it in the key callback. Where we just reverse it. That's what I thought I pressed. Anyways, the other thing, I'll go through the file loaders in a second. But the other thing that I added is I made this GLM common, which has the common includes for GLM stuff, mainly the vector and matrix stuff. I really just vec3, vec4, matrix, whatever, and I can just add any other includes that I need to. I decided to go with I reverted back to the shaders that just had the flat color with the color override and normals, just because we're going to extend into lighting and we'll need the normals eventually anyways. So I'm kind of upset that this isn't just starting where I wanted it to. I thought I left it wherever I made the changes. All that really changed, I left these all in the files even though we're not using them, but all that I changed is the reading this. Yeah, I changed the structure Took out the RGBA because I'm not using it. And then here, took out the loading the RGBA because they're not in the files anymore. And then took out the copy color because they're not in the file anymore. Okay. So now I'm going to be going back and forth between the Word document for our requirements. Already showed the code for the camera. It is interactable. I'll show how it works when I run it. Where is it? Ability switch between. Oh, here it is. Description of the scene, models, locations, and initial camera position must be described in an external file so that it can be changed and edited without rebuilding. Why do I have an error? Why Visual Studio are you doing this right now? Yeah, I don't know what this is. Add semicolon at the end of previous token. What the what? Okay, sure, whatever. Visual Studio. Excuse me. Anyways, so I took this in two ways. First is load models from file. So we pass our program into it. I declare some string streams that I'm going to need. This is the location of our text file, which I can open from the solution directory, common, assets, models, and here's our models to load txt. Everything that we want to load from our models is here. As I mentioned before, just using normals and vertexes. So we open the file, check that it's open, excuse me, and then pass through using next token. I kind of made this for the media fundamentals project one and just reappropriated it for loading the ply models. This is more complicated than it needs to be because it is error checking for spaces in the file names, but I don't do the same error checking in the world file, so the file names need to not have spaces in them. So model requirements need to have no spaces in them, and in the files to load, I opened it a second time, the extension needs to be included. Basically, we've get the next token. We go to that file. So the first one should be this bun zipper. We push it back onto the model locations vector, which is a vector containing all of these paths. And then we try to load the model into the VAO. If it works, we print that it worked. If it didn't, we print that there's an error. And again, this is just error checking if there's spaces in the name. But again, that error checking is not in load world file. I decided it would be easier to just make sure all the files had no spaces in them while I was making the world file. So then we have the load world file. So I can just close that now, which is up a level in the assets folder. And I decided to add this little explanation. So we start with the model name, including the extension, and then we have the X, Y, and Z position of the object in the world. We have the X, Y, Z rotation in degrees of the object, then the scale of the object, and then the RGB values of the object. So, same idea. Open the file. And always make sure to close the file before we finish. Open the file. Make sure it's open. So get away the throwaway text. This can just be removed. And also the camera, which is just XYZ position. Of the camera. So if this token actually says camera, then we know we're in the right spot. This can just get thrown away if we ever remove the header. I just kept it as an explanation. Again, sorry I'm rambling. Sorry I feel like this is taking way too long. Anyways, get the camera XYZ position. But if we're, for whatever reason, in the wrong position, just break out of here. Also in both files, I end the file with the end token just to make sure that we break out. So never call, or you can call something, like you can name something with end in it, as long as it's not just entirely end, nothing else. It is looking for this exact code to break out of the while loop. But we just go through per model. We get the model, make it and add it to the mesh name, go to the next token, get the XYZ position of the mesh, get the XYZ rotation, add it to the mesh, get the scale, get the RGB, just set the override to true for every single mesh that we have, and then push the mesh back onto our vector of meshes, which allows us to just load everything. Close the file when we're done. So again, none of this really changed. The only other thing that changed is the... yeah, just making the mouse callback, set cursor position callback, and making the cursor invisible. And loading the files is called... program from file. Oh, here it is. Added them to error checks just in case something goes wrong. We break out and end the program. Load the models into the VAO, load the world, and then fix our camera, draw the world. So static scene, really simple, but dynamic because I'll just run this to show that it builds properly. I mean, I already showed that it builds properly, but it runs properly. I have all the warnings about converting from doubles the floats and everything, and yep, here's the little scene that I drew. So I have the camera positioned here for the moment. Pressing W moves the camera forward wherever I'm facing, W backwards, left, moving left along wherever I'm facing, right. I made the Skyrim camera without the zoom out functionality. Pressing E, I can move the camera up and down. Pressing space, we switch between wireframes. So now we can see that there's another little crystal here. So some of our requirements was that we need to load at least 4 models, at least 4 different models. So just to go over them, I have the bunny, I have this chair, I have these pillars, I have this archway thing, I have this crystal model. This is a bookshelf model. It's kind of hard to tell without lighting and textures. And then there's this upside down little bowl thing with a little bunny hiding in it. And this floor model, just so that there was something that everything looked like it was kind of resting on. So just to show, I'm going to minimize that. We've got our world file, and let's just put the camera along the z-axis. And instead of running it from Visual Studio, I'm going to just run the exe. And ta-da! Camera's in a different spot. Let's just make it even more obvious. Go to 4:4. And now we're over by the bookshelf. And all I did was change the position in the world file. So obviously the file's only being read once at the beginning. So I couldn't change this while the program's running and it affect anything. But now let's just quickly... the other thing is that I got these models from Runemark Studios Dark Fantasy and Creepy Cats 3D Sci-Fi Kit, which were both part of different Humble bundles that were suggested to us. I kind of like the Dark Fantasy stuff, so I went with more of that. Anyways, once I'm done the camera, I'll change that. So I have this turret simple that is not in the world at all yet. So just to show, here's the turret. I've already done it so that it removed all the textures and everything. Already forgot which color is which for the axes. Oh, there it is, Z. So X is red, Y is green. So it's going to load into the world like this. Whatever, roughly. So we are going to need at least 90 rotation around the x-axis when loading this so that it is at least somewhat sensible. But let's just also show the normals. There they are. So as was pointed out, recompute vertex normals, and then normalize vertex normals, and then export the mesh into this folder, solution, common assets models, name it something with out spaces, include normals, do not include binary encoding, and that's it. So let's add the turret. If you don't add it here to the models to load, it does not have the model in the VAO manager, so it can't load it. But let's just go back to the executable, run it again. And if I Alt-Tab to the console, shader compiled okay, loaded all these models, including the turret. And then I forget where I actually have this print, but it prints each of the actual models in the scene, just the name of it. And I hit escape and it crashed. That's fun. Might be because of Streamlabs running. Anyways, so to actually add the model, I have so many things open. So let's copy the name, put it before the end. Let's just put it at 000 for now. It needed at least a 90 rotation in the X. Let's just leave the Y and Z for now. No scale. And let's pick, let's see, what would be a nice color? Maybe, I already have pink for something. Let's try 153 in the red. Just a nice dark red color. Save the world file. Run the executable. I think I'm gonna need to, wait, that's not the right file. That's not the right model. That's not what you want to show. While recording your submission. Yeah, that's the floor. Why is it loading the floor? $3 a.m. Yeah, that looks like a turret to me. And I know it's loading that last part because it's red. Yeah, that is just the floor model. Why? Floor 01 script B turret simply 01 apply. What? What is happening? And it crashed again. Good God. Now when I'm trying to record. No. Actually, yes. Show me that you don't work when it's not there. What? I mean, of course, it's loading the wrong file. Why wouldn't it? Okay, so it's not there anymore. Good. I'm sorry, I'm just a little flabbergasted that this singular model is doing this. Now, of all times. Turret. Turret.ply. Load it into the VAO. Loaded turret.ply. Just why do I have so many things? Turret.ply 000 90 00 scale 1. I forgot what color it was. That's not the right tab. 153 0 0. Right. Name XYZ 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 scale RGB XYZ scale RGB. Yeah. So load it and display it and not be the floor. There it is. That is a very massive turret under the floor. Well, needs to be scaled down, repositioned, rotated, whatever. So that's just 0.2. Probably needs to be raised. Try 3 units, rotate. Let's just rotate it around and put it at like -5. That is still massive and far too high. 0.02. Anyways, that's all you have to do to add a new model. Oh, now it's tiny. Hello. Hello, tiny turret. Anyways, yeah, I just made a simple little static all hail the bunny queen scene. I wanted to use the bookshelf because it shows that from one side you can see the stuff, from the other. It's just the solid wireframe. We can see everything. Here's our teeny little turret. Teeny tiny little turret. Reveals the bunny, the Jester bunny. And oh yeah, not including the turret because I just added it as an example of how to add things. At least 4 different kinds of models. I have the bunny, I have the biodome, the chair, the bookshelf, the crystals, the pillars in the arch, and I believe I did 11 or 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, plus the turret. Oh, and the floor. And the turret added as an example. Models that we can use can be changed by changing the model file. Yep. Just make sure that they're following the shader. Description of the scene model's initial camera. All described here. Interactively controllable. Yep. And alright, I'm gonna remove all the unnecessary stuff and zip up this folder. Sorry that that's a 40-minute long video. Have a good day.